Hello students, now today we will do numericals on the Maxwell node analysis. In previous class already I told you in node analysis what we will do. In node analysis, first of all you consider the node, then consider a planar network, then choose a difference node or datum node, then apply the considering node 1 and node 2, the conductance matrix into voltage matrix equal to your current matrix. Then find out the node voltage V1 and V2. In this problem, here there is a V1 and here there is a V2. The question asked calculate the V1 and V2. So what we will do? First of all, this is a current source, no problem. And here also there are two current source. One is 2 ampere, another is 4 ampere. If there is a current source, so nothing is worry. But if there is a voltage source, we have to convert it into current source. The current source, there are two current source, slightly you modify the circuit. This is your V1 and V2, this is your V1 and V2. In V1 and this is a datum node or reference node. So V1 there is a 2 ampere and 5 ohm, 2 ampere, and I have converted the resistance into conductance. So already I told you the reciprocal of resistance is conductance. If there is a resistance 5 ohm converted into the conductance 1 by 5, that is your 0.2 mho. Reciprocal of resistance is conductance. If there is a reactance, reciprocal of reactance is susceptance. Reciprocal of impedance is admittance. Y equal to 1 by Z, G equal to 1 by R, and 1 by X equal to susceptance sigma. Here 5 ohm resistance converted into conductance 0.2, 1 by 5. Here there is 10, 1 by 10, that is your mho, 0.1. And here there is 2 ohm, 1 by 2, that is your 0.5. And here this is your V2, same potential, here same potential, here same potential. That's why your V2 like this. Okay. And here that is your 10, that is your 0.1 mho. Then if you considering the node 1, this is node 1 and this is your node 2. Then apply what? Conductance matrix G into V, that is your I. Okay. So like in loop analysis, resistance into current, that is voltage. In there is a current is unknown, here voltage is unknown. Here voltage, that means node voltage, now we are going to calculate. Conductance into voltage, that is your current. Here we will find two nodes V1 and V2. If there is two nodes, there are 2 into 2 conductance matrix and two unknown voltage V1 and V2, we have to find out the value of V1 and V2. Already I told you that is your G means what? G11, G12, G21 and G22. This is your conductance matrix. Then voltage matrix, the two node voltage V1 and V2 and current I1 and I2, net current. Like in case of loop analysis, the net voltage in the loop 1 in case of loop analysis, but in case of node analysis, the net current considering the node 1, here I1, I am considering I1, the net current, what is the incoming and outgoing current, what is the net current considering the node 1, that is your I1, and what is the net current at the node 2, that is I2. So G11, already I told you, G11 is nothing but what? Sum of the conductance connected at node 1. How many conductance are connected at node 1? Here, there is one and another one. So that is your 0.2 and 0.1. Sum of the conductance connected at the node 1. There are two resistance here. I have converted into conductance. There are two conductance. One is 0.2, another is 1. So in case of G1, I can write 0.2 plus 0.1. This is nothing but G1. G11. Sum of the conductance formed at the node 1. That is your G11. Next G12. G12 means conductance connected between 1 and 2. The conductance common between 1 and 2. This is node 1 and node 2. Here this is conductance is common. Put the minus sign. So that is your, in place of G12 you put the minus sign, minus 0.1. Are you clear or not? Similarly G21, 1 to 21 is same. That is your 0.1, 0.1. Then 2, sum of the conductance connected at the node 2. Node 2, how many conductance here? 1 and another one, 0.1 plus 0.5, 0.1 plus 0.5. This is your conductance matrix. what? That is your what? V1, V2. Okay, then equal to current. Only one current, that is your incoming current 2. There is no incoming or outgoing current considering the node 1. Only one current, that is your 2 ampere. If you will find in node 1 there is only one current, that is your 2 ampere. So that's why in place of I1 I can write, refer to the node 1, there is only one current plus 2 ampere 2. If you will consider the incoming current is positive, outgoing current is negative. So here incoming current I am assuming positive, that's why it is 2. In place of I1 I can write 2 ampere. Similarly I2, the net current at the node 2 only 4 ampere, so that is your 4. Are you clear or not? This is nothing but conductance into voltage equal to current. The matrix will like this. So if you simplify this, 0.2 plus 0.1, that is your 0.3. So 0.3, then minus 0.1, 0.1, then 0.6. This is your conductance matrix. To unknown voltage V1, V2 equal to, that is your 2 and 4. So easily you will calculate the unknown values voltage V1 and V2 using Cramer's rule. The two unknown values V1 and V2 we can calculate. First is your G. The value of G is how much? G value using 0.6 into 0.3, 0.6, 0.6, G equal to 0.6 into 0.3 minus plus 0.1 into 0.1. Okay, the value is around how much? That is your 0.6 into 0.3, that is 0.18, 0.18, 0.18 minus, that is your 0.1 into 0.1, that is your 0.01, this is your 0.01. The value will be how much? That is your 0.18 minus 0.01. The value is your 0.17. That is your 0.17. Okay, G. So then what we will do? How to calculate V1? How to calculate V1? When you are calculate V1 is how much? Using Cramer's rule. So 3 column, first column, second column and third column. When you are going to calculate V1 means if you close this one, that is your 2, 4 using Cramer's rule, 2, 4, then minus 0.1, 0.6, this divided by your determinant, value is your conductance G, 0.17 divided by 0.17. It is around how much? 0.6 into 2 minus plus 4 into 0.1. This is your V1. Similarly, V2 value, how to calculate V2? How to calculate V2? How to calculate V2? V2 is how much? V2 using these three Cramer's rule, 1, 2 and 3, V2, simply you close the second column, 0.3, 0.1, 0.3, 0.1, another is your 2, 4, this divided by how much? This value G equal to how much? 0.17. So V2 value is how much? V2 equal to, that is your 0.3 into 4, 0.3 into 4 minus 2 into 0.1. The value is how much? That is your here in V1, 0.6 into 2, 1.2, 0.6 into 2, that is your 1.2, here 1.2 minus 0.4, that is your 0.1 into 4, that is your 0.4. 0.4, the value will be, that is your 1 minus 0.4, the value is your 1.2 minus 4, that is your 1.2 minus 0.4, 0.8, 0.8 volt, that is your V1. So V1 is your 1.8 volt. Then calculate V2 here, that is your 0.3 into 4, 1.2 minus 0.2, that is your 1 volt, 1 volt. So V2 equal to 1 volt and V1 equal to 0.8 volt. Okay. So in this method, using node analysis, the three loop, in case of loop analysis, if there is a 3 loop, if you consider the node analysis, it is very much faster or easier than previous one. So here you will find the V1 equal to 0.8 volt and V2 equal to 1 volt. If there is 2 node, the 2 into 2 conductance matrix will form conductance into voltage equal to, that is your current, and the 2 unknown values V1 and V2 we can calculate. So here are some tricks, that is your some techniques to rerun the circuit. So here there are some techniques how to rerun the circuit is very important. If the circuit, if there is some complex circuit, first of all you have to simplify, and then when you are going to follow the loop analysis, if there is a current source, convert it into voltage source. If you are going to follow the node analysis, convert the voltage source into current source. So some of the techniques you have to follow so that your calculation is much easier. If this type of circuit is given, so how to if you rerun the circuit is like this. Look at this here, A, B and B, C. Here this is nothing but A to B are A. Then here this point, this is your B and this is your D. Okay. Similarly here C, in C to B, C to B, C to B, there is your RB. Here RB, this is your RB. A, this is nothing but your A to B, this is your RA. Then B to C, that is your RB, B to C, that is your RB, B to C, that is your RB here. Similarly A to D, this is nothing but your D. B to that is your A to D, that is your RB, A to D, that is your RB. Then D to C, that is your RA, D to C, that is your what? RA. So a very simple network you will find. If this type of circuit is given, first mark as A, B, C, D, and only you will find these your 2 resistors are in series, here 2 are series, and you can easily calculate. If this type of circuit is given, you can rerun this type of circuit. So another one is like this. Here R1, and similarly this is your R4, again this is your R4, then R2, then here R5, then R3, then R6, and like this. Easily calculate this resistance is parallel. Whatever this equivalent resistance, that will be series and this will be parallel. Then whatever this resistance, this will series and this will be parallel. If this type of circuit is given, not confused, first of all rerun the circuit and your calculation will be much easier. This is your R1 here and this is your R1, this is your R2 and this is your R3. From R1 here there is an R4, this is your R4. What is the equivalent resistance? R4 parallel R1. If you again rerun the circuit, R4 parallel R1 is 1 resistance here. Similarly, this is your R2, this point, this is your R2, this is your what? Whatever this resistance R1 and R4, whatever this resistance, this is your R1 and R4 is parallel. R1 parallel R4 is 1 resistance. Whatever this, suppose this is your X, Rx, again what? this Rx plus R2, Rx, this is your Rx, this Rx is series with R2 plus R2, Rx series with R2, then parallel with what? Parallel with what? R5. Again, if you will solve this, then again this is whatever this is series with what? R3, series with R3. Whatever this, that will be parallel with what? Parallel with R6, parallel with R6. So in this way you can easily solve. Another problem is like this. Suppose R1, R2, and this, and look at this, this type of, like this. This potential, this potential, this potential, this potential is same here. What will do? If this potential and this potential, this is same. You can write this R1, R2, and this is your voltage, and this is your let R3 here, R3. This resistance is R3. Okay. This R4 will not found because what? This R4, any short path parallel to resistance, that will be short circuited. Any short path, and there is a resistance parallel, what? The equivalent is your what? No, short. There is no potential here. Is short path parallel to resistance, that is your short. Okay. So next class we will do another more and more number of problems. So today we have discussed some numericals related to nodal analysis, and next class again we will do more and more number of problems related to nodal analysis. Thank you.